அருள்மிகு பழனியாண்டவர் ஆர்ட்ஸ் காலேஜ் ஃபார் உமன், பழனி, Department of Chemistry. I am Mrs. T. Anandi, Assistant Professor, Department of Chemistry. Today we are going to discuss about magnetic properties of lanthanides and actinides. Magnetic properties of lanthanides. The paramagnetic properties of an ion or an ion is due to the presence of unpaired electrons. Both lanthanum 3 plus and lutetium 3 plus ions have no unpaired electrons. These are not paramagnetic. All other lanthanum 3 plus ions shows paramagnetic properties. Since most of lanthanum 3 plus ions, the energy difference between two successive J levels of the multiplet, there is a strong LS coupling. In these ions, the unpaired electrons n-2 f orbitals are quite deeply seated and hence are well shielded by 5s and 5p electrons from the effects of other atoms in their compounds. This is crystal field effect. The effective magnetic moment of lanthanum 3 plus ions are given by the following equation. It is provided by ground state symbol of lanthanum 3 plus ions. Here, J is the Landy splitting factor. It is represented by 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. Where S is the resultant spin quantum number, L is the resultant orbital quantum number, J is the resultant inner quantum number which is obtained by coupling L and S. Values of magnetic effective of sulfates of lanthanum 3 plus ions calculated from the equation 1 and those found experimentally are given in the table. From the table, following points may be discussed. Lanthanum 3 plus ions, there is a almost good agreement between the calculated and the experimental values. We know that lanthanum 3 plus ion like La3 plus and Gd3 plus and Lu3 plus which have S term symbol. L is equal to 0. There is no orbital effect. The equation reduces to mu effective which is equal to mu S which is equal to 2 into square root of S into S plus 1. The values of mu effective calculated from these two equations are given in the table. Calculated and experimental values of magnetic moment of sulfates of lanthanum 3 plus ions. The values are shown in the table. Magnetic properties of actinides in the F5F series, Pu35 and Am3 plus ions shows the analogous behavior as noted for Sm3 plus and Eu3 plus ions in 4F series. The magnetic properties of the actinide ions are considerably more difficult to explain than those of the lanthanide ions. The values of magnetic moments found are calculated using Russell-Sanders coupling scheme. An equation used for the calculation of molar susceptibility is given by the following equation. Here, N is the Avogadro number and G is the Landy splitting factor. Beta is the Bohr magneton, J is the total angular momentum, K is the Boltzmann constant and T is the absolute temperature. The above equation can be applied only to the gaseous ions. A comparison of plots of magnetic susceptibilities of tripositive lanthanide and actinide ions against 4F and 5F electrons. This is the magnetic moment of actinides and lanthanide elements. Next, the plot of lanthanide ions has 2 humps while that of actinide ions has only one. In both the cases, the first hump is however at the identical place. This shows the magnetic moments of actinides and lactinide elements. The movements of lanthanide ions agree closely with the theoretical predictions, but those transuranic ions are somewhat lower than the expected. This is because 5f electrons of the transuranic ions are less effectively screened from the crystal field, which quenches orbital contribution than are 4f electrons of the lanthanide ions.